Okay, let's get started. If you have a quiz 4, please turn it in like now. Because I'm sure everyone wants to see me scroll down on this PDF. Anyone not turn in quiz 4? 5, 4, 3, 2, 1. Oh, okay. Yeah, it's fine. For the people who are not yet turning it in, are there any questions otherwise? About, yeah.
Yeah, so I'm trying to input a text file from
Yeah.
your assignment section to C line.
Yeah.
It's having trouble recognizing apostrophes.
Apostrophes. Okay.
And the data type. So calling every word, thinking it's a variable data type.
So are you reading your assignment 5, you mean, or assignment 6? 6. So you're reading line by line, and what's the issue?
So every word is saying I'm missing a terminating character in the apostrophe. So I'm trying to use dotting more, but I don't think it works for this.
Well, it shouldn't have to do that because all the characters are ASCII. Maybe we should talk offline. Yeah. There shouldn't be any issue because it should be plain text, but maybe it's something weird with the file. Sometimes that there are like these weird characters that are invisible, and it could cause something to not work. Yeah, we can talk. Other questions about assignments, other stuff? Yeah.
In assignment 5, we create a class called Big Int, which we have parameters of another big int.
So that means like you're taking the argument and the type of the other argument is int as well, capital INT. Yeah, so it's being able to work with yourself, which is the current big int that we have, as well as working with another big int. So like we're multiplying one big int times another big int, and the only way we can do that is with a passing it by the parameter. Other questions, though? Yeah, go ahead.
Yeah, so when it comes to like starting off an array, we have to do int and then the name of the array and then the
Square bracket, yeah.
Why? Okay, so let me ask you this. It's more of a technical question than a logical question. Why is it the square brackets are the ones we have to do and not like say parentheses?
Because this goes really deep into C++, but the parentheses and even curly brackets in some cases correspond to initializing one int. They've just decided semantically that square brackets means an array. They could have equally said parentheses are for an array and square brackets are for initialization. They could have equally said that.
So it basically said don't question it.
It's just what they decided it to be. And yeah, it's just that they defined it to be that way. Yeah.
You can get the value and .hat or
Yep. Yes.
So which I'm guessing that just without bounds is a little bit faster.
Yeah, it's a little bit faster, but for pretty much our purposes, unless you're doing something like assignment 4, it's just not going to matter. So I wouldn't worry about it. You can use .at, that's fine. So the question is, square brackets can get elements in a vector or an array, but there's this function called .at for vectors that gets the element at some index in a vector, but it also does bounds checking, whereas the square bracket operator doesn't. So it's like, which one should you do? One doesn't have bounds checking, one does. It depends on the situation. If you need performance, use the square bracket. If you don't, then just use .at. Okay, you guys are really late. You better turn in like right now. Other questions? Okay, so when the last person turns it in, I'll scroll down. Okay, so no one else can turn it in now. So quiz 4, Question 1 is just printing in reverse. So just start at the highest index, which is the length of the thing minus 1, as we've talked about, and keep going down until you reach 0, and then subtract 1 every time. And therefore, we print the array at that index with a new line. There are other ways of doing this, so this is not the way, the only way to do it. You could have just done from I size and print IDX minus 1 and go while IDX is at least 1. That would work equally well. So that shouldn't be too hard. Second one is where we have, so put it right here, please. So here we have an empty vector, and then we just go from 1 to n and push back every single value in that order. So we push back 1, push back 2, push back 3, all the way to n. So this one wasn't too hard either. And I assume that int n is declared above, but that's not the important part. The important part is being able to use pushback. There's this other function that I know of that we haven't talked about, but it's useful for this particular question called iota, which allows you to populate a vector or any structure really with values from a certain range to another value. It's not required. If anyone used it, that's totally fine. It's just I wanted you to be able to use pushback. Question 3. I'm proud to say I've used the Cauchy-Schwarz inequality in my research one time, so I'm totally happy about that. Cauchy-Schwarz inequality from quiz 4. Yeah, so this one is not, it shouldn't be too hard. So what you're doing here is the first part, you figure out which of the two vectors was the smaller one, and you add zeros to the smaller guy until they have the same length. So if the length of the u vector is more than the v vector, we add as many as we need, which is the difference of the lengths, and then we push back 0 into the v vector, which is the shorter one. And then otherwise, we calculate the other difference, and then we push into the u vector zeros. And then after that, we just do the sum. So I keep track of the sum of the left side, which is the stuff inside the parentheses here before I do the square. And then the right-hand side u, which is the sum of the squares of the u elements. And then RHSV is the same thing for the v vector. So then I just add to the corresponding sums. Then the left-hand side is just the sum I just calculated squared. And then the difference is the u times v right-hand side minus the left side. And then I print the difference. So this one shouldn't have been, it might have been a little tedious, but it's not difficult. It's not anything that we haven't seen before. But any questions on quiz? So hopefully I'll get this graded by Monday. Okay, so we're gonna actually do something slightly different today. So I can't believe it took until this point, but one student emailed me about they want to see more code examples in class. Who wants to see more code examples in class? Okay, so universal. I thought that was a good idea too. So unfortunately, the student didn't get back to me about any particular problems that that everyone wanted to be seen. So what I had to do was I had to think, well, is there a problem that's interesting but also easy to implement and applicable to the world in general? So what I thought would be best is to do things in my research. So we're going to do some programming, live programming. I did not prepare this in advance, so prepare for bumps in the road. So here is a thing in my research. So I'm interested in arrays of this form. So what is this thing? So this thing is called so maybe let's make notes. So this thing is called a PHF. And what that stands for is a perfect hash family. Okay, so a PHF has 4 parameters that I am going to give to you. So n here corresponds to the number of rows in this thing. So the first number right here says 6. And so are there 6 rows in this array of numbers? Not including the first line, just the lines. Yeah, so there's 6 lines of numbers right here. The K right here says how many columns are in the array. So the second number here says 13. Are there 13 columns in this thing? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Ah, good. So there are 13 columns in this thing. The V parameter right here says how many different symbols are in the array. So are there 3 different symbols in this 6 by 13 array of numbers? Yeah, so there's 1, 2, and 3. The number itself does not matter. It's just that we have 3 symbols to play with. So these first 3 parameters are, okay, I define this array of numbers and it has this many symbols, so what? I could, for example, remove one of the symbols entirely, and it would still be a PHF at this point. But the last parameter is where things get really interesting. So what is this T parameter right here, which is 3 in this case? So here's what happens. Pick any 3 columns that you want, any 3. They don't have to be adjacent to each other, any 3 that you want. So just as an example, maybe I can pick the first 3 columns, and I'm indicating them by V's. Okay, so pick those 3 columns. Then what has to happen is there's some row only in those 3 columns that has all different symbols. Okay, so for example, in this row, are there 3 distinct symbols in those 3 columns only?
No.
No, good. What about this row? Yes, good. So not in this one, not in this one, not in this one, and not in this one. Let's pick a different set of 3. So I could have picked this, this, and this. So is it? Do we have 3 different symbols in these 3 entries only?
No.
No, so we have a 1 and a duplicate here, which is 1, and 2 here. What about this row? Yeah, so I have a 1, 3, and 2. So note that it doesn't have to be 1, 2, 3 like this. It could be in any order at all, as long as they're all different symbols. Okay? And I have to check this for every choice of 3 columns. If I leave one set of columns out, that might not actually work. Okay, does anyone have any questions on how this is defined? Yeah.
So what is semicolon after that?
Yeah. Yeah. So a good question. So in this definition right here, I put a semicolon right here. Why am I doing that? That's just due to history. So the way that people define this is that they did it this way. So this actually leads into what I'm going to say next. So there are many questions you may ask about, okay, if I give you these 4 numbers, does there exist a perfect hash family or not, right? So for example, does there exist a perfect hash family on one row where I have V symbols right here, as well as that's the number of columns as well? Do I have a PHF on one row like this? I can actually show you it. So 1, 2, 3, 4, ... up to V. How many columns am I using here? If I am really going up to V here, I'm using V columns, right? And I have V symbols to play with. So I really do have one row that I can use here. So no matter what T is, if I pick any T columns in here, they must all be different, right? Because if I pick 3 or 4, anything, there's no duplicates at all anyway. So therefore, I have a 1 row PHF. What about this? I had 1 more column, but I still keep the number of symbols the same. Well, I must pick one of the other V symbols to put in the V plus 1th column. Let's just say it's 1. Remember, the values themselves don't matter, but it's just that we must pick some value there. Well, is this a PHF now? No, because if I pick, let's just say T is 3, for example. If I pick this column and this column with any other column, are there all 3 different values? No, because I picked a duplicate value. So what I'm interested in is how small can we make these things? Okay? So something called the PHF number, the N stands for number, where I just give you the number of columns, the number of symbols, and this T parameter is the smallest N for which a PHF on that many rows exists. Okay, so if I have V plus 1 columns, then there definitely isn't one of 1 row, as we just argued here. Okay, so that goes back to your question, which is why is there a semicolon here? I think it's because that of this quantity where we're taking the N out and the KVT are kind of tied together. I think that's the reason, but I don't actually know the reason for sure. Yeah.
But does T have to be greater than 1?
Yes, yeah. So there are vacuous conditions such as K has to be at least V, which is at least T, which is also at least 1. Because if I have this T thing being larger than the number of symbols, I'll never get any row with all distinct symbols. Because if I pick, let's just say V plus 1 columns, and there are only V symbols to play with, then I must have a duplicate somewhere no matter what happens. Same kind of argument goes for this condition here. And T has to be at least 1, because if T is 0, then it doesn't say anything interesting. Yeah.
What does T stand for again?
So it doesn't stand for anything, but the common name denoted to this is called the strength. I didn't actually say that, but that's what's usually called the strength. So if I have 3 right here, that corresponds to strength 3, okay? Because if I'm making T larger and larger and larger, I'm asking more and more of the array to hopefully get distinct values in some row. But the key is that some row has elements which are different. Yeah.
So it just seems like if T is 1, then you're always going to have
Yeah.
data.
Yeah, so T is 1, that's not an interesting example either. But sometimes we do need a strength 1 thing, but the vast majority of the time we set T to be at least 2. Yeah.
And how can this be applied to real life?
Great question. So why would this ever be useful? So I'm not going to give you all the details because I can spend the next few hours discussing this, but if we want to test your program, like let's just say you turn in your assignment 5, which has the functions on them, how do we make sure it works? Well, how many integers can I pass into the set bit function? A lot, well, 32 in this case, but a lot in general, right? So do I necessarily need to test all those cases? Well, if you can figure out, okay, I can group all of these possible inputs as this one case, then if I just pick one element out of this set of cases, then all of the others effectively are tested at the same time. Well, that leads us to think, well, okay, if we need to test all of these different components in this integer class that you're making, well, it may be okay if we just use one of them only, but maybe if we use several of them at the same time, something may go haywire. For example, if we are trying to test whether an operating system works, or maybe some application across operating systems work, well, maybe that the cases we need to test are Windows, Mac OS, Linux, maybe other operating systems too. But maybe this application has something to do with your native browser, so we need to be able to test Chrome, Safari, Internet Explorer on all, maybe not all, but some of the systems. So then you have to think, well, how are we going to test all those possibilities? And so being able to generate test suites that are small number of tests is always good. And what PHFs allow you to do is they allow you to make test suites for large applications. So does that answer your question? So they help you make test suites for large applications.
Essentially, speed up the runtime on how to run the program.
Speed up making test suites. They don't help the program itself. They help you make the test suites that we can run on against the program. And we can talk more about offline about how exactly that happens, but that's the main application of them. Other questions? Okay, so I kind of got a little started here. And this goes back to your question, I think, about files maybe. So here I've included this array of numbers as well as these, as well as the four numbers N, K, V, and T up at the top. And then what follow are N rows, each of which have K columns. Okay? So what I did so far is I created what is called an if stream. So this is related to your assignment 6, which is an input file stream. Okay? So here we're asking, in the directory where this file exists, which is the same directory as the project, call this. I'm going to open a stream, which is kind of like cin and cout in some ways. But what we're going to do is we're going to declare integers, and I'm just going to read the first line. Okay? So here I declared the nkvt just like before, and I'm going to read in the values from the file. Okay? And then, just as a test, I'm going to print the 4 values. Okay? So if I run this, then hopefully we get 6, 13, 3, and 3. Oh, wait, we get zeros. Anyone know why? This really is attempting to read a file, but anyone know why? It's something to do with C-line. Yeah. Yeah. No, this really is the location of the file. I guarantee it is. Or relative to the main CPP file is what I'm saying. It's something specific to do with C-line, which is it's not able to look up this file because it's by default looking somewhere else. It's not looking in the project directory. So the way to fix that, and this is related to your assignment 6, is go to Run in the menu up here, and then go down to Edit Configurations. So the configurations here is specifying some arguments about whether some files are in some folders or in other folders. And the one you want to look at is working directory down here. So the way to set that is click the 3 dots right here. And I'm already in the project folder right here. And then I just push open, apply, and we're all set. So then now if I run this file again, I get exactly what I want. So now I can read the file. Any questions on how to do that? Yeah.
So if I was
Then you don't have, there's no such thing like this, yeah. If you're compiling via the command line, you don't have to do anything special, yeah. You got another question? Okay. Any other questions though? Okay, great. So now we have to think, okay, we're going to be reading this file. We've successfully read this nkvt first line. So the first line will always have 4 integers, always. But what might happen afterward is dependent on what the number of rows and the number of columns is. So first of all, let's think about what structure should I use for this? What is a reasonable structure? A 2D array? Would an array work here? I mean, technically yes, but what's the issue here that you saw with your lab 8 if you tried to use an array? Well, the number of elements in the array has to be a compile time constant. If I feed some other file into this, can I necessarily figure out at compile time the number of rows and columns? No, not necessarily. I would have to know that at runtime when I'm actually reading the file. So what is a better structure for this? A vector. so that I can handle everything in the same way, and as well as doing it at runtime. So I've included vector here. Should I use a 1D vector or a 2D vector? A 2D vector sounds like a better idea. So, and first, now we got to think, well, what questions should we ask about this? So, if I look at these first 3 columns again, if I change this to a 1, what should I say about the entire array? Is it a PHF now? No, because the first 3 columns, no row has 3 distinct values in it. So what we could ask about this array is it a PHF or not? Okay, so we're just going to do a checker for a candidate array, whether it actually is one or not. Other questions you might think, well, okay, you could give me the 4 values, and then I have to answer the question, does there exist one? Or maybe you only give me the last 3 values, and you ask me, what is the smallest number of rows that any PHF has? Interesting questions, but they're beyond the scope of this class. All we're going to do is a checker here. And actually, this was going to be on your exam 3, a part of it at least. So think of this as a warm-up for your test 3. So we got to make a 2D vector. So let's make a vector of vectors. Let's just call it PHF. Okay, so, and I'm going to promise you that the file really does have n rows which follow, and each one has k columns. So I'm not going to trick you with false input or anything. So do we know how many rows are going to be added here? Yeah, how many rows are going to be added? N, right? Well, 6 for this file, but in general, it's whatever I just read from the file. So I know that there are going to be n things that are going to be inputted. So let's make a loop that just loops n times, and each one reads 1 line of the file. Well, what's the best loop for this? N. Sorry. I'm thinking the wrong thing. For loop. Why a for loop instead of, say, a while loop? Because I can actually write to say it has n times. Could I use a while loop if I wanted to? Yeah, that would work equally well, but for loop is better for this case because it's easier to write. So I'm going to make a variable called row, and row is less than n, row plus plus, to say this loop now is going to loop n times. Okay? Well, for this row, I better add 1 vector to my PHF to say this is the vector I'm going to add as the new row. So here I'm going to say vector of int is the new row to be added. It has nothing in it now, but we're going to be reading in values as we go along. Well, for this row right here, do I know exactly how many elements are going to be added to it? How many columns am I going to add to this 1 row right here? In this example, 13. But in general, how many am I going to add? K. So I better have a loop right here which loops k times, because I'm going to add each one to this new row vector, and I know exactly how many I'm going to add, which is k. So I'm going to make int call, so for column, call less than k, and then call plus plus. Although here we actually don't need the column, or the row actually, but it's just to specify how many times the loop will iterate. Okay, so now we got to read 1 value from the file, 1 more value from the file, and then add that 1 value to the new row. So how do I read 1 file from an if stream or cin or anything? Well, let's make a variable to handle that value. So let's call it int val. I haven't read the value in yet, but how do I read 1 value from a file? Well, we actually kind of know how to do that, which is with the in-stream operator, the two greater than symbols. Just like with if stream, we can do the same thing here. So here we can just say the input stream from the file, we're going to read one value into this val variable. And then now what do I want to do with this val variable? Put it into what structure? It's not a rhetorical question. Let's step back. So this is the entire array that I want to have at the end, which holds the values inside the file. This is one row that I'm going to add one row at a time, second row, third row, fourth row, all the way to the last row. So right now, I'm going to be processing values in this row only, one value at a time. So I know exactly how many times I'm going to do that, which is k. So here, I'm going to read one value from the file, and I'm going to add it to my row that I'm currently making. So the row so far has 0 elements in it, nothing at all. But I'm going to be adding elements to this row. So if I wanted to add val to this new row, what should I call? Not Ghostbusters, but what else should I call? We can do insert, but what's a better way? A pushback. Yeah, so I can do new row dot pushback val. So I'm going to be putting in k values into this new row, which is what we want. Each row has k values in it. Okay, so after here, we are done adding things to this new row right here. What should we do with this new row? Put it into the PHF. Because we're just making a new row right here. We got to put it into the structure at some point. So how do I put something into a vector? Same answer as last time. Pushback. So PHF, the whole array, we're going to push back one row right here. New row. So let's just recap. I have a 2D vector right here. I'm going to add to the strategy we're going to do is add one row at a time. So the inner for loop right here is just to process one row and one row only. And so in this scenario, we're going to make a brand new vector with nothing in it. And then what we're going to do is we're just going to read k values, the number of columns from the file. The file doesn't know where it is, but we know that there are going to be k of them. And in this case, there are going to be 13. So then we're just going to keep adding them to this one row right here until we're done, which is when we exit this loop. And then when we're done adding things to this one row, let's put it into this 2D vector. And that's what we do here. So let's just make sure that we really are doing things correctly. So let's print the PHF right now. Yeah, go ahead.
So what you basically did was you took the text file and you put it into a vector here.
Mm-hmm. Yep, so all we're doing so far is we're putting something from a file into a vector. That's all we're doing so far. So then what we're going to do here is I'm going to skip some things. So just to show you how to actually do this quickly. I've done this hundreds of times, so I know exactly what's happening. But if we print this, it'll print the array exactly as we want. So what is actually, can anyone explain to me what's happening in this for loop, in this double for loop? We're printing something definitely, but what is actually happening? Well, what does the colon right here signify with respect to the for loop? Range-based for loop. So let's see. For every row in the PHF, what type is row here? Int or what? What is the type of each element in this PHF? A vector of int. Because if we look inside the angle brackets, we see vector of int in there. So the type of row is a vector, one row of the array. What is calls type right here? So it's looking for every element of row. What was the type of row again? Vector of int. So what type is column here? Is an int as well, which is the actual value in the array. So we print the element with a space after it. What does this new line at the end do? Yeah. Right. So once we're done processing one row, we start on the next line. Okay? So once we processed printing one row, we start on the next line, and then we do the next row until we're done. Any questions on being able to print this? I'll put all this code on the website, by the way. Okay, so now is the interesting question. We gotta look at the array, look at every t columns, and see whether or not there's some row that has all different values in those t columns only. And so I've kind of written this for you. So it's kind of a bit of code. But let's try to step through how this actually works. So there's some terms in here that you don't need to really know, but it's just the point of this is understanding the high level idea first. So this class right here, so I'm going to give you the number of columns and this t parameter, the strength, and then what it's going to give to me back is the set of t columns to check next. Check these ones, then check these ones, check these ones, and then at the end it'll tell me, oh, you're done. And then you don't need to check anymore. So here, it's going to give me I'm going to pass it the number of columns and the strength, and then I have some private values, k and t, which will be used in the class. So think about how that works. So I'm going to pull this class and say, here are t columns. Or rather, I'm going to ask the class, okay, what are the next t columns? And it's going to give me t columns. What is a good structure to give me t columns in general, or t elements for that matter? Well, what's the best structure to give me t of anything, or any number of anything? An array or a vector, right? So here, the calls internal variable right here is going to hold the t columns that it's going to give back to me. And in fact, you can even see here when I ask it, okay, what are the next columns here? It's going to give me back the columns after some pre-processing, but we can talk about that too. And this parameter this function just resets everything, but you don't need to understand how it all works. But think about this. So if we look at this, so let's just say that we have 0, 1, 2 as my 3 columns to pick. Well, there are many ways we can say, okay, what is the next set of 3 columns to pick? But one way we can say it is 0, 1, and 3, and then 0, 1, and 4, and 0, 1, 5, and etc. Let's just say that the 13th column, index 12, is here. So I can't increment this guy anymore for my next set of columns to check. So what should be my next thing to increment? Is the second element, because I can't increment this guy anymore. So I have to increment the second one. But what should be the third element in this next one now? Should I check 1 right here? No, why? Yeah, it's already been checked. Should I pick 2 here? No, why not? There's no use checking a column and the same column because that's not going to tell me anything. So what should be the next element? 3. So that's what's going to happen. And then I do 0, 2, 4, 0, 2, 5, 0, 2, 6, etc. What if I get to, I just keep doing this over and over until I get to 10, 11, and 12. Well, I can't increment this guy anymore. Can I increment the second one? Well, if I do, then it's going to be 12, but then that means I'm not going to have something for this guy anymore. Oh, can I increment the first one? No, I can't either. So this will tell us you're at the end. You're done. You don't have any more columns to check. Okay, so that's actually exactly how this class works. So all of this code right here, you don't have to understand exactly how it works, although it's a good rite of passage. But the main point is that can you understand the high-level idea of how it works? And that's how to use any class in general. So I'm just going to take this code on blind faith. I'm not going to assert that it is correct or not. It is, but let's just not worry about that. But if I want to use the code in that class, what do I need to do? We need to include it with quotes instead of angle brackets because of many reasons. But we're going to include column iter like this. So it's a class, so I can make an instance of it. So let's make column lex iter. I'm going to call it call_gen, column generation. And remember, the call iter class takes the number of columns and the strength as input. Well, those were just inputted k and t up here. So here I can just say k and t. Well, let's look at the functions that it has. It has some function which says has next, which says, do you have a next set of columns available for me? Don't generate them for me yet, but do you have them ready? And this just checks and says, yes, that is true. Well, what we can do is say, while it does have a next set of columns to generate, let's actually generate them. So let's do while call_gen.hasNext. While it has columns to generate, we're just going to keep going and then check another set of columns. So, but then we actually want to get the set of columns out of this call_gen thing. So if we go back, we can see that there is a next function which returns to us a vector of ints. So this will give us back the columns that we want to get. So then I can just say auto, because I don't want to type it, calls equals get them out of call_gen with the next function. Okay, so we can actually print these. So calls is a vector of ints. So we have to do the same thing that we did earlier for auto call in our set of calls. So for every element in our calls, print call with a space and then a new line, just to see that it actually works. So it's the same trick as before, just applied in a different setting. So then if we look at all the output, we get a lot of set of columns. And in fact, we get exactly what we were seeing before. So it really is working here. Okay. So great. So we can print the columns. That's fine. Now is the hard issue. So we need to get the values out of the columns row by row at a time and see if there are any duplicates. Okay, so what we're going to do is we got to proceed row by row at a time. So is there a nice way to iterate over the rows in the array? Yeah, just use the range-based for loop that we did before. So for auto, or whatever, row in our array, then we need some way of getting the values out of the columns. So I only want the values in this row and in these columns. I don't want any other values. So we're going to make a vector which has the which is going to hold the values that we want. It's initially empty. We're going to call it vals in row. It's going to be empty, but we're just going to proceed through the columns here and then just add them as necessary. So this is actually pretty simple to do. So for every column in our set of columns, we're going to add what to our vowels in row? Well, we got to push back something. Well, let's see. So row is going to be the vector of integers in this row, and the column is the index into this row that we want. So in fact, the thing we want to push back is row of column. So get the index of that column back into this vowels in the row. So we're just looking at, say, these three columns. Let's just do an example. Look at this first row, and let's just consider the first three columns. So it's going to push back 1, 2, and then 2 again. Okay? So it's just going to push back those three values, and then our vowels in row vector at this point is just going to be those three values and nothing else. Okay? So now what we need to do is check, are there any duplicates in vowels in row? So if this vector has any duplicates, then this row is not good. We need to move on to the next row. Okay? So let's see. So now we got to think, okay, we have something that needs to check for duplicates. Does anyone know of a structure where we can put things into it, but it doesn't have any duplicates? Anyone happen to know? So let's see. Let's search the internet for C++ no duplicates for a vector. So this is not exactly what I want. Okay. So this is the thing that I was going to ask you on your test, but obviously I'm not going to now, is something called a set. So a set, all it is really is the same thing to us as a vector, but it doesn't have duplicates. Okay? So that's the only difference here that we really care about. So what can happen? So we're going to make a set, and we're going to put things into the set. If we happen to put something in the set that's already there, nothing happens. But if it isn't there, it puts it in the set. Okay? So I don't think we'll have a lot of time for that, but let's just get started anyway. So in fact, what we can do instead is use a set of integers instead. And then we're just going to put things into the set and then do something after to check for that. But of course, it lives in its own header, so we need to include that header. But it works exactly the same way, and of course, pushback is not a function in it. So let's explore what functions it has. So it has other functions, but the one we want to use is insert. So like the vector class, the set class also has insert. So let's see. Let's think about what is really happening here. So let's just assume that there are no duplicates at all. So we're inserting a whole bunch of things into this set, whatever it is, and it has no duplicates in it. Can you tell me something about the size of the set now? We're putting T things into this set, and there are no duplicates. I'm putting no duplicates in. What is the size of the set? T. Let's suppose I do put a duplicate in. I'm putting T things in, and some of them are duplicates. What can we say about the size of the set? It's less than T. So if at the end of all this, the size of the set is equal to T, what can we say? These columns are good. Okay? So all we need to say now is if the length of this vowels in row set, which is we call size, just like a vector, if it equals T, then we print calls are good. So there are other things we need to do, but this is the main idea. But let's just see. But let's just say that it really is not equal to T. Does that mean that these columns are bad? In this one row, if they're bad in this row, are they necessarily bad everywhere else? No, I have to check every row. If any one of them is good, great. If none of them are good, then I'll need to say something. So very quickly, what we can do is say is, well, we're going to make a bool. I guess I can't get to it, but any questions on the general idea here? Way above your head, it's totally fine. But I hope that you are able to see that everything that we've learned so far, there's nothing exotic here other than set. But you can make set yourself with the things that we know. So I'll see you all on Monday.